All right, so now we're going to look at a solid that will require the vertical washer method to find the volume. All right, so let R be the region in the first quadrant bounded by y equals x squared plus 1, y equals 1, and x equals 1. All right, and we want to find the volume of the solid obtained by rotating R about the y-axis. Okay. All right, so let's make our sketch. All right, now we're only concerned with the first quadrant here. Okay, so x squared plus 1 looks like that. Has a y-intercept of 1. See, y equals 1. That's a horizontal line. So it's going to touch right there. That's 0, 1, that point. And now we're going to have the vertical line x equals 1. All right, so then we have this area. There's the area in the first quadrant. All right, and this point here we're going to want to know. That's where x is 1. Now you could find what the y value is by substituting it into the equation for the parabola, and that's 1 squared plus 1, so that's 1, 2. Okay, so now let's rotate that around the y-axis. Now let's draw what we have. All right, so we basically have this little piece here. And that's going to be flopped over the y-axis. All right, and it's rotated. So it looks something like that. We can kind of get a better idea by adding some more circles. Okay. So it's kind of like a bowl. It's a bowl shape. So we're going to need to use the washer method. And we know that because we have some missing space here in the middle of it. So it's like a bowl. You could fill it in with liquid if you wanted to. Now these parts here, this is solid here. And it's solid all the way around. But there's an inside there that's missing. Okay, so that's why we use the washer method. All right. All right, so we're gonna need to our formula for the washer method, and it's a vertical axis, so this is gonna be a dy integral. So volume equals pi times the integral from a to b. Keep in mind a and b are y values of capital R of y, so that's the large radius squared, minus the smaller radius squared dy. You might see other parentheses around that. Okay, so we're going to need to figure out what our two radiuses are and what our bounds are. All right, so let's think here. We know that our large radius, that's from the axis of rotation all the way to the outside curve. Okay, and if you notice, that's actually always going to be the same. No matter where you slide that up vertically, that's always the same length. So we say it has a fixed length. So capital R of y, so let's see, our volume's going to be pi integral. So capital R of y is just that length there, that fixed length, and that length is 1. We're going to have 1 squared. Right? That length is always 1. So it's kind of like a cylinder. The outside is a cylinder, and then the inside is like a bowl. Okay, so now the small radius, that's going to be from the axis of rotation to the inside curve. Okay, so that is given by the formula for that inside curve there. Okay, and we need it in terms of y. And that inside curve we know is y equals x squared plus 1. We want a function of y. Right now this is a function of x. So we need to solve for y, or sorry, solve for x. So we have y minus 1 equals x squared. Now we square root both sides. And we get that x is equal to the square root of y minus 1. All right, there we go. So this formula is actually going to give us the length of our inner radius, the smaller radius. Remember, you could remember that the formula for, r of y squared is equal to the inside curve minus the axis of revolution squared. Right, and capital R of y is outside curve minus axis of revolution squared. Our axis of revolution is given by, it's the y-axis, so that's x equals 0. So we don't need to bother writing the minus 0, so we'll just write y minus 1 squared. This is dy. Okay, so lastly our bounds. So remember our bounds are the y values. It's the vertical range of our area. In other words, it's this to this. This is our vertical range from here to here. Okay, so that's going to be from 1 to 2. 1 to 2. All right, so we take our integral from 1 to 2. So that's a vertical range of our solid. And go ahead and compute this out. Okay, you should get pi over 2. All right, so do that out for yourself. Compute that definite integral and just check that you get pi over 2.